Hello, welcome, and I hope you can hear me all right. My name is Patryk Jakubowski, and today we'll be talking about CSS Grid. And I would say we have a lot to talk about today. So much, in fact, that I had to split this presentation into two separate presentations to fit all the content. So today we'll be talking about the CSS Grid itself, what it can do for us, what properties we have available, what we can do with it. And then in second presentation, I have different examples, use cases, practical layouts that we can use in CSS today. So let's start with the short story of the layouts, because as you already know, the layouts are not something completely new. We have them for a very long time in printing, in books, in magazines. And the first web was not really something that was very heavy on the layouting and styling stuff. So the first websites were mostly text, some hyperlinks, and that was pretty much it. We also had images, and as it usually is when people are limited by the technology of their time, they really get creative. And so it was no different with the CSS and HTML, because remember, at this point of time, we didn't have CSS at all. There was no standardization between browsers, basically at all. Each browser had their own technology. And so if you think about it, creating layout like this today would not be very difficult to do. But back then, we don't have paddings, we don't have margins. So you can think for a moment how you would go about creating a layout like this without any kind of CSS. And this is, as I said, a real website from 1996, though this is the navigational page. So each of those images is a hyperlink to another page. And how it was done is with spacer images. So this is one interesting hack from the time when we used a very small image asset, in this case 1x1 GIF, with the same color as the background. And then we used width and height, the HTML properties, to adjust this spacer to fit the use case of laying out those elements the way we want. And so we also had tables at that time. And you can see that the tables were used for layouting for a very long time. This is the first eBay website from 1997. And you can see that even in 2006, you can still see that all this page is created with tables. But in 2002, we had a new type of layouting tools available because we had CSS. So Internet Explorer 5 was one of the first browsers that implemented the full specification of CSS1. And with that, we got access to, among other things, floats. So floats are meant to be used for wrapping content around some elements. And you can know that mechanism from Microsoft Word, for example, when you would use the same kind of tool to wrap the text around the images. And you probably already know that the float was a go-to solution for layouting for a very long time, because again, creative people, limited technology equals creative solutions. And working with floats had its disadvantages, like you need to remember that you need to clear the floats. But quickly we got the frameworks that abstracted away all the complexities of working with the floats. And so a lot of libraries and frameworks started to use floats to give us the column-based grid layout for us to work with. And this was a go-to solution for a very, very long time. As a matter of fact, you can right now still use the floats when using some of the frameworks available on the web. So this is pretty much the end of the history of the layouting, and we are getting to the more recent modern stuff. So throughout the presentation, I will be using a few examples, like you can see here, the container and item. And we are getting to the more modern stuff when it comes to the layouts and CSS. So one thing that you might know already is Flex and Flexbox. So what Flex allows us to do is to lay items both horizontally, or either horizontally or vertically. And this is one of the use cases of Flexbox, but it also gave us a lot of properties and attributes for working with responsiveness. Like we could wrap elements, we can make them flex, shrink, or grow to adjust to the changing space. And now we have a new tool in our toolset, which is CSS grid, a new display property value that we have available. And as you can see by default, if we just slap the display grid on some container, it will just lay our elements vertically, the same way we saw in the Flex. And to be honest, we can do the same thing that we done with Flex by default with grid. We just need to remember that grid by default will try to stretch our items, our elements, to fit all the space available in the grid. So to get the exact same result, we would need to change the justify content to start. And now we are getting the similar result for grid and for Flex. And so this is as much as we'll go for the history stuff. Now let's talk about the grid anatomy, or rather the definitions and terminology that we'll use throughout the presentation. So if you just use display grid, you will get the container, which will contain all the stuff related to the grid. And inside of the grid, you will get columns and rows, and you can call them both tracks. So the column is a vertical track and the row is a horizontal track. And at the intersection of the two tracks, you will get cells, which are places, slots that you can place your elements into. And you can also see that you have gutters or gaps that allows you to create a spacing in between different elements. And the single most important thing about lines, about the CSS Grid, are lines, which we'll be using a lot throughout the presentation, and you will see why pretty soon. And of course, we then have grid items, which we can place in a different cells throughout the grid. And one difference between the cell and an item is that not every cell needs to have an item in it, and also one item can span multiple cells. So with that, I think we can talk about the grid basics and what we can do with CSS Grid. So when we create a grid, by default, we get a single column, and then all of our items will be laid out vertically. And as we can see, if we look at the tools in the browser, we will see that we get one column, and then we have additional rows created by the browser, by the grid itself, to accommodate all the items that we create. And we can also create more columns easily. And you can see that the grid will try to lay our elements row by row, column by column, as much as it has the columns available. And we can create more columns as we go. And as you can see, if we keep adding more items, they will be added to the grid by creating additional rows by default, implicitly by the grid itself. And we got a few new interesting properties with the grid. So one of them is the gap. So one thing that you might have noticed throughout the presentation is that we have some kind of spacing. And up until now, I was using the margin to achieve that, because otherwise those examples would not be very aesthetically pleasing. So there are some problems with margins, though. One of them that is indirectly related to margins is content overflow, and the other one is that if you use margins, you will get the additional spacing at the edges of your container, and also you will have double the spacing in between items. And usually we don't want that. So to work around that, we can create some kind of calculations where we apply those margins, then we negate the edge margins in the container, and also we need to adjust the width to add the spacing that we added within the grid or flex that we used. And we can make that a bit better by refactoring with CSS custom properties. And we can see here that it's the same thing. But as you may have already noticed, we have something called gaps or gutters that we can use. And we can access that in CSS. So right now we have a new way of doing the same thing. So those are two equivalent examples. With a single line of CSS, we get the gaps that work exactly the way we would expect. So they only add the spacing in between the items that we have in our grid container. And one thing to note is that right now the support for grid gap is pretty decent. It's almost the same as for grid itself. So if you are using grid gap is pretty safe. For the Flexbox is a bit worse. So you may want to use the fallback with the CSS Feature Query, where you detect if the gap for Flex is supported. If not, use this calculation hack to get the gaps, and if it's supported, use the gap. And in a few years, you can just remove the fallback and use the gap for both Flex and Grid. Okay, and here you can see that if we just keep adding the gaps, the container will adjust, and we just get the spacing in between elements, unlike the margins. And one thing that you might have noticed is that if we use the percentages with the gap, the effect will be the same as with margins. We'll still have the content overflow. But with Grid, we also got a way to get around that, as you can see in the example on the left side. And the way we can do it is with something called fractional units. So one thing that we also have with Grid is a new type of unit called fractional unit. And you can see that here I'm using percentages to define my columns, but I can achieve similar result. So I want all of my columns to have equal spacing. And I can do that with fractional units. Fractional units can be understood as free space. So I'm saying here that each of the elements should get one fraction of the free space available after we subtract the margins and all the elements that are defined using absolute units, such as pixels. And so here you can see that we don't get overflow. And also one thing that we can use is repeat function. So if you don't want to type 3 times one fraction, one fraction, one fraction, you can use repeat 3 times one fraction and to give you the same result. And one thing to note is that what will happen if you use 2 fractions instead. So here I say that I want to have 3 columns, and I want each column to have 2 fractions of a space. And really what you will get is the same thing that you would get with 1 fraction. And we can see here why is that. So as I said, the fraction works by taking the free space, the remaining space after we subtract the gaps, absolutely positioned elements, and after that assigning the fractions to the elements. So we can see that we are dividing the free space into 6 fragments, and then we are giving each item, each column, 2 of the fragments. And this is the same as if we said divide the free space into 3 fragments and give each column a single fragment. And we can also see it here. So we have 1, 2, and 3 fractions. So we have 6 segments in total. So we are taking the free space remaining after the gap, and then we divide it into 6 fragments, and then we assign the fractions as specified in the CSS. And as I already said, if we have some element that is defined in pixels, we can this also will be subtracted before we get the free space. So we get the container available space, we subtract the gap, we subtract the first column, which is defined in pixels, and then the remaining space will be divided into 2 fragments, which are then assigned as we assign them in the CSS. And here's another example when we have 3 fractions and 2 fractions accordingly. So one interesting use case for CSS Grid and for fractions themselves is to have responsive containers and responsive items without a need to have a media query. So as you can see here, we don't have a media query, but our layout adjusts automatically to the viewport, to the resolution that we have. And the way we do it is that we define the template columns. We use the repeat, but instead of giving it the absolute value, like I want 3 columns, I want 2 columns, I'm saying use autofill algorithm to decide how many columns we need. And then I say each column should take available space, but cannot be the width cannot be lower than 250 pixels, meaning that it will try to fit as many items as it can, as long as they can be at least 250 pixels. And we can see it here. So as long as we have space for 3, it will give us 3 per row. Then we cannot fit 3 items that would have 250 pixels in a single row. So it will create 2 columns. And as we get to the mobile resolution, we don't have enough space to fit even 2 of them next to each other. So it will go to a single column, and each item will take one fraction, which is all the available space there is. So this is a very interesting use case for using CSS Grid to have this responsiveness without need for media queries. And you can see here that we also have a separate algorithm called autofit. And you can see the difference between them here. Autofill will try to stretch your elements to take up all the space available, but autofit will keep adding columns even if there is no content for them. And autofit would be a good use case, for example, if you have dynamic loading. So if you have additional elements that will be loaded asynchronously, dynamically after some time, you would avoid the sudden layout shift after those elements are loaded if you use autofit instead of autofill. And so additional thing that we need to talk about is explicit and implicit grids. So before we do that, I want to make one simple change to our item. So I changed the display to grid just so I can center the content of that element on the center. And this is another use case for CSS Grid. You can easily center elements both vertically and horizontally with pretty much a single line of CSS. And you can also see that I removed the padding because I want the items to stretch and to only take as much space as the content requires. Okay, so explicitly means that we ourselves define columns and rows. And we can see here that we define 3 columns, 1 fraction each. And we can also do the same stuff with rows. So we can say that we want 3 rows. The first one will be 150 pixels, the second will be 200, and the third will be 100 pixels. And one interesting thing that we can do, we can use the repeat function and give it more units than 1. So we can here say repeat 3 times 100 and 200, and we have this kind of pattern when we have 6 rows explicitly defined by us, and they will be 100 and 200 pixels, one after another. And here we can see that we define 2 columns, 1 fraction each, and then we have 3 explicit rows, 200, 200, and then auto. And auto is the default value. It means takes as much space as your content requires. And you might think, looking at that example, that we have 2 explicit rows and then everything else is implicit, because if you look at the styling, that's how it looks like. But because we defined the first row explicitly, we said ourselves that it should be auto, it is counted as the explicit grid. And really, it might be hard to see in this example, but in development tools, you will see that there is a way to tell implicit from explicit grid by looking at the lines. So for the explicit grid, explicit columns, explicit rows, the lines that define your grid will be solid for the explicit grid, whereas for the implicit stuff, it will be the dashed line. It will be barely visible. And as you can see, here we have the explicit grid, first 3 rows, and then we have the implicit grid created by the grid itself as we added more items. And we can see that there is a solid line after the first and after the third row. Okay, so we can adjust the automatic rows. So here we have an example of the grid where we only specify the first row explicitly. We tell it to have 200 pixels height. And after that, we can tell it to use auto columns and auto rows. And here I use the auto columns, but because we are not adding more columns, it has no effect. We have to use auto rows and say that we want 200 pixels for them in order to have 200 pixels in all the rows that are implicitly created. So additional thing to note is that a lot of properties in CSS Grid have some kind of shorthands. So here we can use the grid template to define both columns and rows in a single line of CSS. And up until now, we talked a lot about what to do with the grid itself, how to define it, what we can do with the container. And now we can talk about what we can do with the item placement and the items themselves. So here we have a simple playground. We have 3 by 3 grid where the columns have one fraction and the rows have 200 pixels. And one thing to note is that we can see that the lines, because this is with the development layout overlay shown, we can see that the lines are numbered from 1 to 4 in this case. And we can reference those line numbers when placing our items. So for example, I can say that the grid, that item number 1 should be in grid column number 2. And what this will do, it will move the item to the column number 2. And we can see that all the other items have been moved by one position. But one interesting thing happens if we specify the item number 1 to be both column number 2 and row number 1. So we would expect that nothing changes because it already is in row number 1. But if we do that, you can see that the grid changed. The element number 1 is indeed in the same position. So it is in row number 1 and column number 2, just as it was. But now the element number 2 jumped into the gap or position that element number 1 was before. And if we add more examples to make that a bit clearer, we have item number 1 that is fixed in row number 1 and column number 2. We have item number 6 that is specified to be on row number 2. And we have item number 9, which is set to be in column number 1. And you can see that there are a few things going on. So item number 1 is in the exact position that we specified. Item number 6 was moved to the beginning of the row number 2, and item number 9 was moved to a completely separate new row. And the reason for that is that Grid is placing items using a very specific algorithm. And this algorithm is placing the items with the highest specificity first. So if I specify both row and column, this element is called fixed element, and it will be placed first. So we have element number 1, because it has both row and column defined. Then we have element number 6, because it has the row specified. And then the grid will try to place all the items one by one, going row by row, column by column. And then it gets to item number 9, and it wants to be in column number 1. But this constraint can no longer be satisfied in the same row, so the new row will be created for item number 1. So this is one thing that we need to be aware of when working with the grid, one of the gotchas that we need to remember, that the fixed items are always placed first, and the items with rows specified will be placed after that. So one additional thing to note is that grid row and grid column are really a shortcut properties for grid row start and grid row end. And by default, both of them have auto properties. So we can use that to specify that item number 1 should start at line number 1 for the row, so for the first horizontal line, and then the line number 2 for the second vertical line. And we can also specify that the item number 1 should end at line number 1 horizontally and line number 3 vertically. And this will not change position, as you can see. And the reason is because in both cases, we are specifying the same position. One interesting use case, though, that we can use this for is that I can specify that item number 1 should start at line number 1 vertically and end at line number 3. And now the item will try to stretch in between those lines. And once more, I can also define all the properties, but as long as they are kind of pointing to the same place in the grid, it will have the same effect. So one thing to remember, the takeaway, is that we are using the lines and line numbers and not really the columns or rows. And of course, we can also specify that it should take more space than that, and it will stretch in between the lines that we specify both vertically and horizontally. And so we can use that to anchor elements. And for example, if you want to place element at the end of the grid, we can say that this element should end at the column number 4 or the line number 4, so the last line in our grid. The problem with that is that if we keep adding more columns, then we can see that it's no longer at the end. And we can, of course, adjust that and say that it should now end at the line number 5, but there is a better solution available. As you may have already noticed, each line is numbered in two ways. One is with positive numbers going from left to right, and then we also have the negative numbers going from right to left. And we can reference those negative numbers as well. So we can see that the last line will always be -1. So we can say that element number 1 should end at line number -1. And now if I keep adding columns, it will just stay at the end of a given row. So this is one use case for those negative numbers. And I can also say that it should span from line number 1 to line number -1, and it will give us take entire row, which is not exactly the true, as we will soon see in the grid gotchas. So here we have some line labels, and you can see that instead of using numbers, we can create our own labels for the lines, and then we can reference them in placing or positioning of our grid items. So this is one thing that we can do for more complex layouts. You may not want to use the numbers, and instead you want to actually label the lines with some custom names. So this is how you would do it. Additional thing that we can do is we can size items, and we've seen already that we can stretch item in between lines, but we can also use the span property to tell the element to span, for example, to columns. And we can also use, because we can remember that this is a shorthand property, we can specify both the position and the span. So for example, we are saying here that it should start at line number 1 and then span 2 columns. But we can also say that it should end at line number -1, so anchor it at the end, and then we can again make it span 2 columns. And of course, we can do that with rows as well. And here we are spanning 2 rows and 2 columns. And one problem that you might have noticed already with this is that we have a lot of gaps. And sometimes it might be desirable for artistic purposes, but in most cases, you would want those gaps filled with some items. And if you don't care about the ordering of your elements in the grid, you can do that quite easily with the dense mode. So you can use grid autoflow dense, and it will do its best to fill the gaps in your grid layout. And for example, here you can see that the number 2 and number 6 were moved to fill the gaps, but you have to remember that this is the best effort. So if you don't have the elements available to fill the gaps, it means that the gaps will stay. So this is one thing to be aware of. So additional thing that we have available in CSS Grid are grid areas. So grid areas are a way of labeling the cells in the CSS Grid. So let's create a simple playground where we create 4x4 grid, and then we can use that in our examples. So here I'm using the grid template areas to define different areas in our grid. And you can see that by default, it won't give us much. It doesn't change anything. And if we turn on the overlay, we'll see that the areas were created. And just to show it a bit better, we have 4 areas here. We have area A, B, C, and D. And really the magic happens when you start assigning those areas to your items. So we can say that the item number 1 should be in area A, item number 2, area D, 6, B, 8, C. And you can see that those elements will just jump into places. And if we can turn on the overlay, we can see that they jump into places that we would expect. And one thing to note is that the grid template areas will not create the grid for you. So here I commented out the grid definition with grid template, and I just left the grid template areas. And this is implicit grid. So despite the fact that it looks identical, it is the implicit grid and not explicit. It was not explicitly created by us, and you will see in the gotcha section that this could be problematic. So here we have the example of using grid template instead of grid template areas to use the same CSS attribute to both define the labels and define the columns and rows in a single line of CSS. So here we are defining the labels, but also saying that the rows should be 100 pixel and the columns should be one fraction. And one of the best use cases for the grid areas is redefining the grid using the CSS queries. So here you can see that on different resolutions, we change the grid definition, and we don't have to change anything about the items because they will jump into places automatically. So I think you can, sorry, I think you can already imagine that this could be a pretty powerful tool for layouting, where you can simply redefine the grid for mobile, for tablet view, and you don't have to actually change anything in your markup, in your HTML. So this is a way you can move stuff around on your page, depending on the viewport size, depending on the resolution, without the need to actually change anything in your HTML. So one thing to note, though, is that there are some rules regarding grid areas. So as you can see here, you will not get a donut area A. Instead, your grid will be completely broken. And this is because one rule of the grid areas is that they have to be rectangular. So if you add additional shape, or if you detach the grid areas and create two areas with the same label, those are not the valid definitions. And if you use grid template, it can break your entire grid because you are using grid templates to also define the grid as well as the grid areas. So this is one thing that we need to be aware of when we are working with grid templates. So we can now talk about some things that might seem different, strange, difficult when you start working with the grids. So let's start with creating some grid playground. So here we create a single row and two columns. And now I say that I want to place item number 4 in column number 4. So remember, we only defined the two columns, but when I move element into the column that does not exist, the grid will create this column and all the intermediate columns for me implicitly. And if I move this item even further, for example, to the column number 6, it will create all the intermediate columns as well. And the reason you can see those columns is because I defined also the width for the implicit columns using the auto columns property. If you didn't do that, they will be auto by default, and since there would be no content, you would not see those additional cells. And if I move the elements completely out of the grid, like for example to the third row and to the fourth column, you can see that it's now completely outside of the grid, and both columns and rows were implicitly created for me. So this is one thing to be aware of when you're placing the components, especially when you try to use, for example, the CSS queries, and you forget that you had some element positioned and you change the grid. And this could get you in trouble then. So let's look at another example and another problem. Here we have a simple grid again, and this time we'll be changing element number 4 to span 2 columns. And in here you can see that it kind of looks as we would expect. So it moved to the new row because in the row number 2 there was simply no space. But watch what will happen if I increase the span. So if I, for example, tell element number 4 to span 4 columns now, and we only got 2, it will create additional columns for us as well. And as you can see, again, we get the gaps because there was no element before the 4 that would fill this gap. And we could use, again, the dense mode to fill this gap, but by default, this is the behavior you will get. And if we create additional playground, we can see that everything is looking okay, and only 2 rows and 2 columns are what we create explicitly in this grid. So if we now tell, again, element number 1 to take the entire row by saying stretch from line number 1 to line number -1, it will do exactly that. But what will happen if we tell it to stretch from line number 1 to line number -1, but this time vertically? As you can see, it will not take entire column as maybe you would expect. And the reason for that is that some of you may have already noticed that the negative numbers are only available for the explicit grid, meaning that the -1 starts at the third line. So this is not what you would expect, that the -1 is the last line in the entire grid. It is the last line, or it is referencing the last line of your explicit grid. So this is one thing to be aware of. And if we add additional column, again, implicit column that we did not define ourselves, we get the same result for stretch entire row. It will only take as much space as is available in the explicit grid and not the entire or implicit grid that the grid created for us. And so if we use syntax like that, where we define everything in a single line, we are saying stretch from lines number 1, both vertically and horizontally, to lines number -1. And you might have expected that it will take all the available space, but what it is really doing is taking all the explicit grid. So if we defined only 2 rows and 2 columns, it will do exactly that. And so you might be wondering, is there an easy way for an item to take entire row or entire column? And really the answer is no. So you can't do that easily with CSS Grid right now. There are some proposals and discussions for that, like for span all, span implicit, span explicit. But right now, you would need to do that outside of the grid. So by manipulating the item itself using different mechanisms unavailable in the grid. So one more thing that we need to be aware of is that if we create another grid, and now we place 2 items defined to them to be in the same place, then something strange will happen. You can see that we want item number 2 and item number 3 to be in the same position. And you can see that item number 2 is nowhere to be found. And the reason is that grid will do exactly what we tell it to do. It will place both those items in the same position, meaning that the item number 2 is still there, but it is behind item number 3. And this can be very useful when you want to create overlapping content. So for example, you want some image and you want some kind of text on top of that image. You don't need z-index, you don't need absolute positioning or any of that kind of stuff. You just can use CSS Grid and position elements so that they overlap on the grid, and you will get exactly that. So one thing to talk about is current browser support for CSS Grid. And really, CSS Grid is pretty well supported. You can use it in all the major browsers. And right now, the coverage is about 95, 96%, which is, I would say, good enough. And for the Flex, it's 99%. So what you can do, what you may want to do, is to use CSS Feature Queries to detect if CSS Grid is available. If it is, use it as a progressive enhancement. So use CSS Grid if it's available. And if it's not, fall back to using Flex as default. And one thing to be aware of is to use progressive enhancement. So we are saying if there is grid, use grid, and not the opposite. So if you are not sure if you can use grid, you shouldn't use grid as a default. It's always safer to go for progressive enhancement and use CSS feature queries to detect if grid is available. And one more thing to be aware of is that only the direct child of the grid is used as grid item. So you can see here that we have the grid container, and then we have some wrapper, and then we have items. But because only wrapper will be counted as the grid item, we can see that only the first cell is populated, and then we have all the items inside of the wrapper. And because we usually don't want to change the semantic HTML markup for the sake of CSS, what we can do is to use a new display value content to basically tell CSS to ignore this wrapper. So display contents mean that CSS will completely ignore this particular element as if it was never there. And so here, if we make wrapper display contents, we can see that now the items are treated as a direct ascendant of the grid. And now we get what we would expect and what we would want. The items are used as grid items. And one additional thing you can use is to detect the grid support using JavaScript. And this is useful if you have the very heavy legacy layout. Like, for example, you want to support a browser that needs floats, for example, for layouting. You wouldn't want your users to download all the CSS that is necessary for 1% of your user base. So it's always better in those cases to detect the feature from the JavaScript, and then after that to download the style sheet with the legacy fallback layout asynchronously. So this will mean that this 1% of user will have slightly worse experience, but this will also mean that 99% of your users will have better experience because they won't have to wait for the additional CSS they will never use to load, which is, I think, a fair trade-off. So one more thing to talk about is to list some of the drawbacks of the CSS Grid because it's not perfect right now. So a few problems with CSS Grid. If you go to the v3c right now, to their GitHub repository, and you type CSS Grid, you'll be able to see some of the issues with the specification and feature requests for CSS Grid. You'll be able to see that we don't have subgrids, for example. So if you have grid item as a grid, you cannot reference the parent columns or lines in the child grid. This is something that will come with subgrids, but is not yet available. Also, we don't yet have this possibility to span entire rows or columns. So this is one thing we are also waiting for. One thing that we need to be aware of is that we need to adjust for wrappers. So if you have some legacy layout, for example, in Flexbox, and we want to use grid, we'll likely need to use this display contents to ignore those wrappers that are necessary for the other layouting tools available. One more thing to note is animations. Like, despite the specification saying that CSS Grid properties should be animatable, most of the browsers do not support animations for the grid properties yet. Only Firefox support them right now. And additional thing to note is performance. For the general page layout, it's better than Flexbox. But for example, if you have a lot of grids that are embedded into one another, you can run into the performance problems, for example, in React. And additional things to note is that there are things that you can do with Flexbox that you cannot do with Grid. Like, for example, if you want to have elements in between tracks, this is something you would do with Flex, and it's very hard to do with Grid. And also, if you want to center elements with auto margin within the grid, this is something you can do easily. With Grid itself, you would need to make adjustments to your items. So this is something to have in mind and note when using CSS Grid. So to wrap it up and to give you some summary, I would advise to use CSS Grid for the general page layout right now. Use it with caution, and I would also advise to use Flexbox as a fallback layout right now. And I would advise, if you want to use CSS Grid for your elements, components, I would test for performance if you want to use a lot of embedded grids, because I've seen some performance issue with that. And if you are not in a hurry, I would wait for more features to come into CSS Grid, such as subgrids, for example. And right now, I think it's a good time to learn and start using CSS Grid, but I wouldn't start rewriting all my UI library using CSS Grid just yet. And remember that the grid is not the superset of Flex. There are things that you can only do with Flex. There are things that Flex is better suited to do. So really the way to go is to use both. And one note is to never sacrifice your HTML semantic markup for the sake of using grid. Remember that we have this display contents, so don't remove the wrappers from your HTML completely just because you can in CSS Grid, if it will affect your HTML readability, for example, for screen readers. And I think with that, we covered pretty much everything I wanted to say in this presentation. So let me know if you have any questions right now for me. to answer. And I really don't see any questions popping up, so it's hard for me to say if we are finished already, because I finished a bit early. Okay, I can see the first one. So Arianda Solution has written that the grid is a CSS tool that makes it easier for us to place elements on the site instead of writing the website itself, and I agree. So in general, this is the way to declaratively create the layout of the page in the CSS itself, instead of using the semantic HTML markup. So you can finally have the separation where the HTML is used for your content, and everything, including layout, you can have in CSS and CSS Grid. So this is a good remark about what CSS Grid could be useful for. One question is if the Sass has support for the grid. So since the Sass is a preprocessor, I would say yes, because it is then compiled into pure CSS anyway. So if your browser has a support for the CSS Grid, then the Sass should as well. So the question is if we have 4 columns and one of them has a fixed width, for example, in pixels, and the other ones are in fractional units or fractions, do we have to use min-max for them to work? And the answer is not really. We don't have to use min-max if we just want for them to take remaining space. We should use min-max if we want to define the range of space that they have available. So for example, if we want to give them some wiggle room, but we want to say that they should never go below certain value, like for example, given item should never be less than 200 pixels of width, then we would use min-max for that. So the fractions themselves, if we don't use min-max, they will allow elements to shrink basically indefinitely. So if the elements itself does not have any kind of width specified, they will allow you to get the minimal width. So Adrian is asking if I recommend the CSS Grid in large applications or for optimization purposes. So I would say right now we can treat CSS Grid as a progressive enhancement for the layout of the page. And I would advise to use it for that purpose. So for the layout of the entire page, and perhaps for some kind of list feeds and stuff like that. I wouldn't recommend using Grid for components. For example, if you have React, if you are using React or any kind of other component library, and you want to use CSS Grid, I would use it for layout of the page, layout of the lists or feeds on your page, but I would not rewrite the specific components in Grid yet, because as I said, if you have a lot of embedded grids on the same page, I have noticed some performance drops in React in that use case, be it only in like 6/7 depth of grid. So if you have grid, then in time you will notice some kind of performance drops. But for the layouts and for the pages themselves, I would say it's a good moment to start using CSS Grid for that, with Flexbox fallback if 95% is not to your satisfaction when it comes to support. So do we have, okay, I see we don't have any more questions. So thank you all for tuning to this presentation and for listening. I hope you got something useful and interesting from it. And I hope I will hear you around with my other presentation with the practical examples and some demos of how you can use CSS Grid today in your applications in React. Okay, with that, thank you and have a nice day. Enjoy the rest of the presentation of the conference.